back. So this is where we left off, where I asked you to determine what is the length of a sarcomere just using the A band and I band terminology, and I hope you figured it out. And if not, you sent me an email with your thought processes. All right, so let's go ahead and continue. And in this section, we are going to be learning about the sarcomere and what is going on in there. So we're going to learn about those myofilaments, those proteins, and how they are going to enable this muscle to contract. So at this point, you should be able to look at this picture and clearly see the A band, the I bands, the Z line, and the sarcomere. Okay, so, but you can't draw that unless you're a really good artist, but I'm not. So I'm a stick figure kind of a person. So here's how I would do it, okay? Where the Z lines are, those are the two green lines, okay? So the sarcomere is going to be between those two green lines. Now, the reason why the dark part is dark is because it's much denser with proteins. And in fact, when you look at the stick figure, what you see is red overlapping with blue, overlapping with red and blue and red and blue. Okay, now if we put a whole bunch more, we made them really skinny like the picture, then it'd be super dense like the picture. But we don't need to draw 100 of them. We can get the same effect just by drawing 3 or 4 of them. And the reason why the light band is light is because it only has the red stuff and there aren't any blue things. So the blue are the thick filaments. Do you remember which protein that is? That's right, that was myosin. And the red are going to have, the red lines are going to contain, which protein was it again? That's right, actin. Okay, so notice we're not talking about the elastic filaments yet. We will get there, just not yet. So from one green line to the next green line, between 2 adjacent Z lines, that is a sarcomere. Now, here's what I want you to notice. Turn to the left side where you're looking at those thin filaments, the red lines with the green line perpendicular to them. What I want you to notice that every single red line is attached to a Z line. And then from there, if I'm the Z line, it goes out in both directions towards the middle of this sarcomere and towards the middle of that sarcomere. It doesn't make it all the way, but it's going out towards the middle of each sarcomere. And so you can see that on both of those Z lines. Now, in contrast to that, the myosin sits in the middle of the sarcomere. It's not directly attached to the Z lines, but parts of it overlap, parts of the myosin overlap the ends of the actin, okay? Now, the myosin's really not just floating in space, okay? We'll show you shortly how it attaches. All right, so here's another stick figure. So go ahead, find your Z lines, okay? And so do you see the actin is still red in this picture, but in this one, the myosin is black, okay? And then at the top, it's showing you what the sarcomere is. Or at the bottom, it's showing you an A band on the left, an I band, and then another A band on the right. All right, so let's talk about some more structures. The part of the A band that does not contain any actin, so where all you have is myosin, all you have is myosin by itself. This area is known as the H zone. And in the middle of the H zone, we do have this M line, which holds all the myosins in place, so they don't sag or anything. So we have myosin that's in the H zone part of the A band, and then the other part of the A band is called the zone of overlap because it's going to contain both myosin and actin. All right, that's the first thing, or the first couple of things. So what determines the length of the A band? Look at the A band. Do you notice it starts at one edge of the myosin, and the A band ends at the other edge of the myosin. So it's the length of the myosin is equal to the length of the A band. So then what is the length of the I band? Try to figure it out. How would you define the length of that I band? What's it made out of? Yeah. It's only the part of actin that's not being overlapped by myosin. So you can't say it's the length of the actin because part of the actin is in that zone of overlap. So it's only the actin portion not being overlapped by myosin. Does that make sense? All right. The H zone is the part of myosin without any actin overlap. Sometimes called the bare zone. We're not going with bare zone. We're going with H band or H zone. And the M line is in the middle of the H zone, and it provides anchorage for the myosin and also for some elastic filaments as well. So let's look at myosin. So myosin is shaped kind of like a golf club where it's got this big head where ATP combined and ATPase enzyme combined, and then it has a long shaft. And what happens is we take two golf clubs and you twist the two shafts, and there is your myosin. So now we have two little heads over there. And then we take a bunch of these, then we take two of them and we put them so that the heads are on the outer part, okay? So you've got this long shaft, and then you have heads out here. Now these heads are going to be flexible. They're going to use ATP, and they're going to be able to ratchet by utilizing the ATP. And their ratcheting motion is actually going to be making the muscle contract, as we will see. Not today. Now we take a lot of these double-sided myosin things and we put them so that the heads come around in a swirl in a whole 360. And what those heads are going to do is in order to ratchet, they're going to form a cross bridge. They're labeled cross bridges, but they're actually just myosin heads right now. They will form cross bridges with the actin, but we're not there yet. And then obviously in the middle, we're going to have an area that just has shafts without any myosin heads in it. And so this is where the M line will be, right there in the middle of that bare zone. All right, so that's it for myosin. So what's holding it in place is the elastic protein titin. So titin is this green thing that looks like a spring. It's attached to the Z line, and then it attaches to the myosin. It actually goes on, attaches all the way to the M line, okay? But it's holding the myosin in place. So depending on the movement of the myosin, the spring can be tightly coiled, or it can be stretched out, or it can be tightly coiled again. And this is what's going to allow that sarcomere to contract and relax back to its resting position, okay? This elastic titin protein. All right, so that's it for myosin. Let's turn our attention to actin for a moment. So actin is a protein that's made up of a bunch of little round balls. And what happens is these get twisted. So think of your Mardi Gras beads, which these are, and they get twisted. Okay. So each one of these balls is an actin protein, and each one of these actin proteins has a hole in it. So think of like a hole on a bowling ball, and that's where the myosin head wants to go, into that hole. But actin's a bit of a prude, and she goes, no, myosin head's gotten in the hole. And so actin has a chastity belt called tropomyosin, which is represented by this ribbon right here, this orange ribbon, okay? So there's the myosin head wanting to go into the hole in the actin. So the chastity belt is called tropomyosin. And so it is covering all those holes in all the actins, one hole per actin, one binding site per actin. Now, if the tropomyosin was just attached at the two ends, it would sag, just like it's showing here. So there has to be a third protein involved. That third protein is represented by that little green thing there, and that protein is called troponin. So I'm going to leave my Mardi Gras beads down here because I can't hold three things in my hand. So in this picture, you clearly can see the yellow actin, each of which has a hole. The white linear structure, that is the tropomyosin. Do you see it covering the holes, the binding sites on the actin? And then there is this protein called troponin. And troponin kind of has the structure like a Mercedes-Benz sign with three parts. One part is going to hold on to the actin, another part's going to hold the tropomyosin so that the tropomyosin is covering the binding site on the actin. And that leaves the third binding site available. And that third binding site is for calcium, as shown in this picture. And what happens when calcium comes along and it binds to the troponin, it's like it's adding an extra weight and the troponin moves. And what happens then is it pulls the tropomyosin off and exposes those binding sites on the actin so that the myosin head can form its cross bridge there. So that's it showing in a linear thing. And so this is it showing it in a little bit more detail. When the muscle fibers relax, there's no cross bridge because we have the tropomyosin attached to the actin covering the binding sites because it's held in place by troponin. So if you look on the left, the red myosin cannot get into the binding site on the greenish actin because we have the yellow tropomyosin blocking it. When calcium binds to the troponin, sorry, yellow was troponin and purple is tropomyosin. I should have looked at the picture up there. So when calcium binds to the yellow, that pulls the purple tropomyosin, exposing the binding sites. Okay. That allows the myosin head to form what's called a cross bridge. Okay. And that is what allows the heads to flex and visibly shorten that sarcomere. So I gave you the link here for this, and this is showing the red is the myosin with its big head, the yellow balls, that's the actin, the blue is the tropomyosin, and then the purple is the troponin complex. And you can see calcium coming in, binding to the troponin, pulling the tropomyosin off, and you see the myosin head attaching. And then if you're looking at it, you'd be going, well, what's this green stuff lying in and out? The green stuff is, we will learn, it's ATP, and we'll learn what it has to do when we talk about the muscle physiology. So I don't want to talk about the ATP right now. Okay, so looking at these proteins, they each have a name, they each have a structure. So when we're saying like the thin protein is actin, we're really meaning it's actin with tropomyosin and some troponin on it. Okay. So the contractile proteins, the actin and the myosin, they're going to be doing the work of shortening the muscle fibers. Whereas the other proteins are what we call regulatory protein. They determine when or if the muscle can contract. So that's going to be our tropomyosin and the troponin, because if they're covering the binding site, if there's no calcium, then nothing can happen. So here is a photomicrograph with a drawing so that you clearly can see myosin, the myosin heads, the actin, and the cross-bridging forming. So take a minute and look at that picture before you continue. So if you recall that the myosin heads went in a whole 360, and this one blue is myosin, okay, and red is actin. So myosin heads can interact in a whole 360. So in skeletal muscle, one myosin can actually form cross bridges with 6 different actins. And if you look at any one actin, like for instance, take this one here in the middle, what you can see is this actin actually can form cross bridges with 3 different myosins. So there's overlapping. It's not like on the longitudinal flat picture that I can draw 1 to 1. So this mechanism is called the sliding filament model, where myosin is doing all the work. Okay, calcium comes in, the binding site's exposed, myosin head goes in, it retches it closer, shortening the sarcomere, using ATP as the energy source. Okay, so when those myosin heads pivot inward, it's pulling actin closer towards the center of the sarcomere. So it's pulling the actin closer to the M line. Okay, so once it has done its contracting, the myosin head is stuck in the crossbridge until a new ATP comes and binds. That's what enables it to detach, because it wants to be pre-primed just in case there's another exposed binding site. In other words, we don't have calcium come in, momentarily expose the binding sites, and then the myosin heads say, wait a second, I need some ATP before I can form a crossbridge. No, we pre-prime the pump with the ATP. The myosin head is ready to do it. Okay. And so with multiple ratchets, the length of the sarcomere is going to get shorter and shorter and shorter. And so these are more complicated drawings. And so what I want you to do is look at the stick figure drawing, which you're all capable of doing. Okay. In this picture, we have 2 sarcomeres up top and 2 sarcomeres down below where there has been contraction. And here's what I need you to figure out. And you can actually compare the pictures, but go back and look at the process and think about what we've talked already. In contraction, what happens to the length of the myosin? What happens to the length of the actin? Those are the first 2 questions you have to figure out. Do not move on until you have figured out. And your options are, it gets shorter, it gets longer, or it stays the same. Once you know the answers to those, then answer these questions. Now that you know what happens to the length of myosin actin, what happens to the length of the A band? To figure that out, what determines the length of the A band? What happens to the length of the I band? What happens to the length of the H zone? What happens to the 2 Z lines? Here it's not longer, shorter, stays the same. Here it gets closer, stays the same, or it gets further apart. And then what happens to the length of the sarcomere? So these are all questions that you need to figure out. Please do not just Google or look up the answers. I want you to think through the process so that at any time when you have a quiz or a test, you can think through the process and get the correct answers. Okay? So you need to change your mindset. Oh my God, this is too hard. I don't understand any. I'm just going to look it up and memorize it too. This may take me some time and effort. Okay. You can do this. Millions of students before you have been able to figure this out. Okay, you're just as smart as they are. Our greatest weakness lies in giving up. Okay, don't give up on yourself. You need to believe on yourself. And with that, I'm going to end this section, and do not continue until you have figured out that answer. Thank you and have a great day.